Hey everyone, sorry I cannot be with you today to introduce the subject, but I think you'll be fine. Mr. Montanaro used to teach electric circuits, and so you should be good after watching this video. You can read the textbook or you can ask him to help you. So our objectives for today is we are going to define electric current, identify electric symbols for basic circuit elements, and identify and construct open, closed, and short circuits. So these are the terms that we will be working on this unit. Current, ampere is the unit of current, electric circuit, open circuit, closed circuit, short circuit. Like I said, you can read the textbook, pages 472, 474, 475, or also ask Mr. Montanaro. So the first question is that legend has it that Benjamin Franklin flew his metal key on his kite in a lightning storm in order to demonstrate that charges existed, that you could have charged particles. Do you think the story is true? So the question is, what is electricity? So electricity has two parts to it. One is you have electric charges, and then the second thing is that they are flowing. Typically, we think of them flowing through wires and doing usable things for us, like turning an electric motor or running a hairdryer or turning a light on. But you don't have to have a wire in order for electricity to flow. So lightning is an example of electricity that's not flowing through a wire. So we already know how we use electricity, household appliances, personal devices. There are, cars. Pretty much it's really hard to go through an entire day without using any electricity at all. Okay, so the question is, what is electric current? So it is the flow of charged particles, and as we said, we usually want these to go through wires and circuits. And so there's an animation that hopefully will show up on my movie. If you go to page 474 in the textbook, they make an analogy of, if you think about water particles flowing through a pipe, like when you turn on your faucet, electricity is very much the same way. Electrons or charge flows through wires differently than water does, but a lot of the same properties that water has flowing through a pipe, current flowing through a pipe has those same properties, or we can make an analogy of water. So that's a pretty common analogy, and that's how you want to think about charges flowing through a wire, even though it's not how they actually flow. All right, another thing, so when we're thinking about variables, so we've got this new variable that we're going to introduce, which is current. It is measured in amperes, so we like to think about our variable is current and our unit is amperes, so there is a difference between variables and units. The symbol for the unit is a capital A. It has to be a capital A, and most people say amps rather than amperes. So we've got the unit and the unit symbol. We've got the variable, so we need a variable symbol, which is down on this slide. So the variable symbol for electric current is a capital I, okay, if you want to be complete. All right, so how do we measure this variable? So typically we use what's called an ammeter. So we can see the unit is amps, and so we can see the connection between amps and ammeter. But more typically we'll use what's called a digital multimeter, and a multimeter measures a lot of different electric variables. So we can also use a current sensor in our kits, and we will sometimes use that. Now, in order to properly measure current, all the current has to flow into the meter and back out again. So we would connect this here so that all of the current flowing this wire comes here, and then we would connect this like to the other side of our circuit. So what is a circuit? A circuit is a conducting path through which electric current can flow. So conducting path means that we have to be made of metal. You can't have a path that has some paper, some paint, other things in it. Electric current will only flow when there's metal to metal connection and it's bare metal. So we already said the symbol for the current is I. And so we would show this, we're going to talk about all these circuit elements in just a moment, but we would show this 0.3 amps, and then we would have an arrow indicating the flow of current. All right, we're going to skip the human circuit and do a different activity on Friday with this. So one of the things that's important to realize is that charge is conserved. So electric current I must be the same at all points in a simple single loop circuit, okay? So everywhere, this is a simple single loop. It's a conducting path, so we have this all along here, and the current I has to be the same in all parts of the circuit. Why do you think that is? Well, the reason why is we already know that charge is positive and negative. So it's either going to be negative electron or positive proton. Only the electrons move, but that's actual matter. I mean, an electron actually is matter, and matter has to be conserved. And so therefore you can't have charges, electrons or protons, like disappearing or appearing. And so that's why charge is conserved, is because charge is attached to matter. You can't have charge without matter. And so that's why if you have the electron flow or the current everywhere in this simple loop has to be the same because of conservation of mass. All right, now we're going to go into some terminology. This is just straight factual information. So this is called an open circuit. I have a conducting path. This is an energy source. This is an energy consumer, and they are connected with wires, but I have the switch in here, so it's open, and so that's why it's called an open circuit. That's the symbol for a switch. We'll do symbols in just a moment. In a closed circuit, I've got a complete conducting path. I know you're thinking, wow, there's a gap here. That's actually inside the battery, and there's not really a gap. That's just how batteries are drawn. So my circuit is closed circuit going through the light bulb all the way through, so I have a continuous path. I've got a complete path allowing current to flow. So no current, current. All right, common circuit elements. This is where you are probably going to want to put these in your notes because you will have to memorize these. No one is going to give you a cheat sheet. They are not going to appear on an equation sheet, and you will just have to know the symbols. All right, a wire is just a line. A switch, this is important. A line, a dot, another dot, a line, and then this open part of the line. So you have to have all of these elements. You cannot get lazy and just do that, okay? You must have the dots in order for this to be a switch symbol. Batteries, this is something that's important. Technically, this is a battery, but we also will use this for a battery. What you must memorize, the long side of the battery is the positive side of the battery. The short side is the negative. Again, this is not going to appear on any equation sheet. This is one of those things that you have to memorize. A lamp or a bulb, line coming out, circle, and then this this represents the coils in an incandescent bulb. There are actually a couple of different ways, and the way you'll typically see me do a bulb is I've got a little circle and then a squiggle in it representing the filament. That's how I do a bulb. Okay, and then finally a resistor. Again, you cannot be lazy. Line, and then you do zigzag, and then another line. Those should connect. So that's a resistor. So as I said, you're going to want to memorize these because I'm not going to tell you what they are in quizzes and stuff. Knife blade switch. Okay, so a knife blade switch uses a mechanical lever to open or close the circuit connection. Do you remember what the circuit symbol is? Quick test. Okay. Circuit symbol for a switch looks like that. Okay. And this, in real life, this is what a switch looks like. It's got an insulated handle so that when you close the switch, you don't electrocute yourself. And you want to use this handle to close the switch. You don't want to put your finger here. Now, we, of course, are only going to be using small voltages, so you don't have to worry about hurting yourself, but it's just a good habit to get into. Critical thing down here, when attaching a knife blade switch to a circuit, you want to be in the open position, because if it's closed, sometimes depending on your circuit element, you can cause a burst of energy that is not a good thing, and sometimes you might blow out a light bulb. All right. Short circuit. It's when an electron current follows the path of lowest resistance that is not through like a bulb or a resistor. You only have wires. Because there's low resistance, there is a fast flow of energy, and you will heat up your battery, heat up your wires, and it's not a good thing to have a short circuit. But basically, a short circuit is when you just have wire connections to two sides of a battery or two different terminals of a plug. So if this switch is closed, it will cause a short circuit because all of the current will flow through this path, which is the path of least resistance, and none of it will flow through there, so my light bulb will not light. Nothing will flow through my resistor, so if those are helping power a device, or if they're part of a device, none of those will light up. So short circuit is a wire only connection that doesn't allow the rest of the circuit to function. Okay, so you are going to do investigation 17A. It is linked in the next assignment, and there's a video. I made a really short video on where to find the modular circuits kit, how to take things out and how to put them away so that you don't break bulbs or anything like that, and also a quick thing on how to put them together. So you really need to watch that video. Mr. Montanaro has never used these kits before, and so even though he understands the theory of how circuits work, he used to teach circuits, he has not used these particular kits, so watch the video. Okay, he'll be able to help you, but he doesn't know where the kits are. Watch the video, it tells you in the kits. All right, so you are going to get these items out of the circuit kits and put them together. They just slide together. Notice there's a hole on one side and then, I don't know what that's called, on the other, and they just fit into each other. But your circuit will not work unless you add jumpers. So jumpers are these metal plates. They are in the kits as well. If you look at the kits, they have these trays. They're in the middle of the tray, but I don't know if it's on the top tray, middle tray, or bottom tray, but they are in there in a Ziploc baggie. And you have to add jumpers between every element or it won't work, because that's how the current flows. Another thing, there should be batteries in your kits as well. They should also be in the middle part of the tray, but again, I don't know if it's the top, bottom, or middle tray. If the batteries are dead, Mr. Montanaro should have access to new batteries. So just follow the investigation, watch the video, follow the investigation, and you should be fine.